Good morning, everybody. So today we're going to talk about function notation, something that's not difficult, but when students are first introduced to it, they often have a little difficulty kind of wrapping their minds around this notation. Our notes are going to come from page 118 and 119. You will only have a one-page assignment that goes with this as well, page 121. So let's go ahead and take a look at the subject of the day, because function notation is incredibly useful and incredibly common as well. In our last lesson, we looked at functions in this fashion. Y is equal to 4x minus 1. Function notation simply takes the y out, which represents the output, and instead writes f of x equal to 4x minus 1. The two actually mean exactly the same thing, but instead of noting what the output is, here they will list what input we are using in this particular function. When you read this, there's more than one way you'll hear people say it. One way, my favorite way, is simply to say the f of x is equal to 4x minus 1. Sometimes people will say the function of x is equal to 4x minus 1. They're interchangeable, whatever you feel most comfortable with. Regardless, x written here is the input, and y, okay, what we get when we put this input in through our function is still going to be our output. So let's take a look at what they do. Here is that same function written as the f of x is equal to 4x minus 1. They have asked us to find the f of negative 7. So they've told us a single input that they want us to put into this function, and that's what we're going to do. So here we have the f of negative 7 is equal to 4 times, this is where we're going to place our input of negative 7, minus 1. And let's figure that out. 4 times negative 7 is negative 28, and negative 28 minus 1 means the f of negative 7 is equal to negative 29. And that's our final answer in this case. We can state the f of negative 7 is equal to negative 29. Let's do just a couple of these real quick. So here they've given us another function, the f of x is equal to x plus 7. They want us to discover what the f of 5 is. So we have the f of 5 is equal to, and here's where we're going to place our input of 5. And 5 plus 7 is going to mean that the f of 5 is equal to 12. Final answer. Here we have a little bit more complicated one. Sometimes you'll need to place the input in more than one location. Our function, the f of x, is equal to x squared minus x. They want us to discover what the f of negative 4 is equal to. So we're going to write it, the f of negative 4 is equal to, I've taken out the x's, I'm going to substitute in negative 4's in both places that I see those x's. Let's work that out. Negative 4 squared in parentheses is positive 16. Minus a minus 4 is plus 4. 16 plus 4 means the f of negative 4 is equal to 20. Number 9 is another one, but it's kind of interesting. You don't just have to put in single numbers. In this case, they're going to have us, first of all, our function is the f of x is equal to 4x plus 11. And they want us to discover what the f of c plus 7 is equal to. So here we have the f of c plus 7. We're going to plug it into our function. This is 4 times, here's where I'm going to place my input of c plus 7 plus 11. And this does give us a couple of steps to work it out. So let's go ahead and see what we get when we do that. So in this case, I'm going to have to distribute. I get 4 times c is 4c plus 4 times 7 is 28 plus 11. And now I just have to simplify that a little further. 28 plus 11 can be combined. And that tells me that the f of c plus 4 is equal to 4c plus 39. Final answer. Now they keep going with this. There's all kinds of inputs that we can put into it, but we can also use this notation in some interesting ways to write rather complicated problems in a more simple fashion. So for my next series of questions, we're going to use the following 3 functions. The f of x is equal to 8 minus 3x. The g of x will be x squared plus 2x, and the h of x is equal to a negative 5 over 2x minus 1. So in problem number 11, they've written what looks like a rather simple thing to do. They want us to find the f of 4 plus 9. So I'm going to refer back up to my f function, and I'm going to determine what the f of 4 is. So the f of 4 will be equal to 8 minus 3, and here's where I put that input of 4. Let's work it out. That's going to be 8 minus 12, and that means that the f of 4 is equal to negative 4. So now I go back up here, I'm going to replace the f of 4 with negative 4, and I'm going to add 9 to it. And negative 4 plus 9 is going to give me a positive 5. So the f of 4 plus 9 is equal to positive 5. We can even mix these together. In problem 14, they want us to discover what 3 times the h of 2 minus the f of negative 9 is. So the first thing I have to do before I can actually figure this part out, I'm going to have to determine what the h of 2 and the f of negative 9 is. I'm going to look at my h function up here. That gives me a negative 5 over times my input over 2 minus 1. In this case, my input, they want us to figure out what the h of 2 is. So let's substitute in a 2. And that's going to give us negative 10 divided by 2, which is negative 5, minus 1. Negative 5 minus 1 is negative 6. So the h of 2 is equal to a negative 6. We're going to come back and use that in a moment. Let's also figure out what the f of negative 9 is. So I look to my f function. That's 8 minus 3 times my input of negative 9. And that's going to give me 8 minus, now negative 3 times a negative 9 is going to give me, let's see, that is going to be a positive 27. And positive 27 plus 8 is going to give me, let's see, working it out. Okay. So that is going to be a positive 35. 8 plus 27 is going to be 35. So now that I know that my f of negative 9 is equal to 35, I can go back up to the original equation and substitute these values in. It wants me to figure out what 3 times, now the h of 2 is equal to negative 6, minus the f of negative 9, which we've discovered is 35. So this is going to give me a 3 times negative 6 is going to be a negative 18 minus 35, and 18 negative minus 35 is going to give me a negative 53. So there's my final solution. So there's a couple of different parts to solving this. Solve for each function, then substitute those values in and solve the original equation. All right, let's do another one like this. Now this one is a little interesting. This time, instead of asking us to discover what an output is, they told us what the function is equal to. They told me what my output is, and they want me to discover what the input must have been. So in this case, they said if the f of x is equal to a negative 13, find what x is equal to. The function that they gave me is the f of x is equal to 8 minus 3. So what I'm going to do is take the f of x out, and I'm going to put a negative 13 in. And when I solve for x, this should tell me what my output, or what my original input must have been. First thing I'm going to do is subtract 8 from both sides. It's going to be negative 13 minus 8 is equal to a negative 3x. Negative 13 minus 8 is going to give me a negative 21 is equal to a negative 3x. And I'm one step from discovering what that input was. I'm going to divide both sides by negative 3. This is going to tell me that x is equal to a positive 7. So I've discovered X. This is the last kind of problem that they gave us on this assignment, and we'll do a bunch of examples together to get this one right. I look forward to working with you guys in Google Meets.